So we're about to dive into this really mind-bending puzzle that sits right at the heart of how science works. It's all about this weird conflict between what our senses tell us and what simple logic demands. It's an amazing story about how science often makes its biggest breakthroughs, not by trusting what it sees, but by taking a giant leap right over it.
Okay, let me ask you this. Imagine you're at a paint store, right? You're trying to pick a color. You grab a little swatch, swatch A, and you hold it up next to swatch B. To your eyes, they look exactly the same, identical. Then you put B next to C, and again, you can't spot any difference. So in your head, you're thinking A equals B and B equals C. Makes sense. But then you put A right next to C, and boom, they are obviously different shades. How is that possible? What just happened?
And that right there is the paradox, laid out plain and simple. Our senses, our direct, in-the-moment experience of the world are telling us one thing, but our logical brain is screaming that it's just impossible. I mean, if A is the same as B and B is the same as C, then A has to be the same as C. That's just basic logic. And yet, it's not. This isn't just some optical illusion. It's a fundamental contradiction baked into how we perceive reality.
Now, you might think this is just a quirky little brain teaser, but it's actually a really profound problem. It's something that caught the eye of the brilliant French mathematician and philosopher Henri Poincaré. He looked at this and realized, wait a minute, this flaw in our perception is a huge challenge for science, because science is all about precise, consistent measurements.
Poincaré even gave a name to this world that our senses give us. He called it the physical continuum. You can think of it like the raw, unfiltered data streaming in from your eyes and your ears. It's not neat, it's not tidy, it's messy, the edges are kind of blurry, and as we just saw, it can be totally logically contradictory.
And Poincaré, he really didn't pull any punches about this. He called it an intolerable contradiction. I mean, that's pretty strong language, right? For him, this wasn't some minor glitch we could just ignore. It was a deal breaker. You just can't build a logical system, like science, on a foundation that's fundamentally illogical.
Poincaré even went so far as to write out a formula to describe what our senses are telling us, and it looks completely bizarre because it breaks all the rules we know. You've got A being indistinguishable from C and C from B, but at the same time, A is clearly different from B. Now, this isn't bad math. This is a perfect description of the messy, illogical data our senses are actually feeding us. This is the raw material science has to start with. Okay, so if our senses are this unreliable and contradictory, how in the world does science build its beautiful, elegant, logical theories? Well, here's the kicker. It doesn't try to fix the messy data. Instead, it does something way more audacious. It takes a bold, creative leap right over the whole problem.
See, Poincaré insisted that there's this fundamental gap. He called it a point of rupture between the world we actually experience and the world science describes. You can't just smoothly connect the dots from one to the other. To get from our messy perception to a clean scientific theory, you have to literally jump across this abyss.
And this amazing solution has a name. Poincaré called it the discontinuity jump. It's not a physical jump, of course, it's a cognitive one. It's that crucial moment where human reason makes a choice. It decides to abandon the contradictory data from our senses and instead to create a clean, abstract, and perfectly logical model of the world.
All right, so science makes a jump. Cool concept, but how does that actually work? What are the tools that reason uses to pull off this incredible trick, to create solid knowledge out of our flawed perceptions?
Well, you can kind of break it down into 3 steps. First, and this is a big one, reason just decides to abandon that messy, contradictory formula our senses gave us. It just throws it out. Second, it creates something totally new to take its place, an ideal, abstract, mathematical model. And finally, it enforces a super strict rule within that new model, perfect transitivity. It basically declares, from now on, if A equals B and B equals C, then A must equal C, and I don't care what your eyes tell you.
And this really shows you the 2 different worlds we're playing in. On the left, you've got the physical continuum. It comes from our senses, it's messy, and it breaks the rules of logic. But over on the right, you have the mathematical continuum. This isn't something we discovered, it's an active creation of our own minds. It's not a photograph of reality. Think of it more like a perfect logical map that reason builds to make sense of the chaotic territory.
So the real power move here, the secret sauce of science, is this thing called the abstraction of transitivity. Now that sounds fancy, but all it really means is that science makes a conscious choice to trust a perfect abstract rule over our own flawed direct perception. It's basically a triumph of theory over raw experience. So, what's the big deal? Why does any of this matter? Because this idea has huge implications. It completely changes how we should think about scientific knowledge itself. It tells us that science isn't just about passively discovering facts that are already out there. It's about actively constructing the very frameworks we use to understand the universe.
All right, let's boil this all down. What are the big takeaways? First, our senses, as useful as they are logically flawed. They just can't be the solid foundation for science. Second, scientific theories aren't just snapshots of reality. They're active, creative constructions built by human reason. And finally, abstraction. This ability to create perfect rules, that's the essential tool that lets us build universal knowledge from our individual, messy experiences.
And all of this leaves us with a pretty fascinating and maybe even a little unsettling final question to think about. This whole process, this discontinuity jump, is based on creatively ignoring the messy details of our direct experience so we can build a more perfect, logical model. So, if science has to ignore parts of reality in order to understand it, what is it truly describing? That's definitely something to chew on. Thanks for joining me on this one.